Welcome back to Conscious Truth. Now, this will probably sound ridiculous to most people, but I've been looking into ideas about whether or not the Earth actually rotates. And of course, at first that sounds totally ridiculous, but there's a lot of things that are actually quite strange when you look into the subject that don't quite make sense. For instance, something that came to my mind was the fact that when a circle, or when a sphere, or you can talk about a circle, it's basically the same principle. When a circle rotates, or imagine this is the Earth, it could be a sphere, but obviously an inner circle, or the circumference of the Earth, the ground, let's say it's down here, and let's say this is the upper atmosphere. This is the circumference is the upper atmosphere. So the ground would be down here. There'd be another circle here. So basically, that inner circle, that circle which is closer to the center, is going to rotate slower because it has a smaller circumference and it rotates the same. It takes the same amount of time to do a complete rotation. So let's say it's midday and you're standing here. It takes 24 hours to get back to here again, whereas this upper circle also supposedly gets back to here after 24 hours, so therefore it must have gone faster. Now, I thought this was very strange because I've been looking into, why does the atmosphere rotate with the Earth? Obviously you've got gravity, which is holding it down, supposedly, but that is not what causes it to rotate, which is what I originally thought. It was something to do with gravity, but it isn't. I asked a couple of people on these physics forums. So you've got this physics forum, which has got a lot of people on there who are supposed to know what they're talking about. And I asked a question: if the Earth's atmosphere spins with the Earth due to friction, which is what I was told in another question, I was told that basically the reason why the atmosphere rotates is because if for instance, say it was not rotating at some point millions of years ago, then basically the friction from just the trees and the mountains and stuff would have actually caused the atmosphere to begin to rotate with the Earth, and eventually over millions of years, not over millions, however long, it would eventually just rotated in sync with the Earth. And I thought about that, and I was thinking, well, the air is very, viscous. Friction doesn't really work very well with a gas or a liquid. And the first thing I thought of was this question, was that if the Earth's atmosphere spins with the Earth due to friction, why is there no horizontal spiraling dragging effect? What I mean by that is, if you imagine that there was another circle inside this one and that was rotating, then you could imagine there'd be friction just near the surface, which might move the same speed as the Earth, but then there'd be layers, and each layer would be pulled along slightly out of sync, so you'd get a sort of spiral effect. You would get a sort of spiraling drag effect. As one circle rotated, it dragged the next layer, that dragged the next layer, that dragged the next layer, and this would cause a sort of spiral effect where each layer of the atmosphere would be moving out of sync. Okay, so this is the original question I asked, and I said here, imagine a bucket of paint. Imagine a bucket of paint with a spinning ball inside it. So the ball is the Earth, and the paint is the atmosphere. And the paint would form a spiral motion and would not all move in a synchronous movement with the ball. To clarify, in order for the Earth's atmosphere to appear to us to be still as it does on a windless day, the upper atmosphere, well, this is what came to this conclusion afterwards, actually. But anyway, this is the next point, is that in fact the upper atmosphere must actually be moving faster than the lower atmosphere. Like I explained here, this outer circle has to go faster to remain in perfect synchronous motion. So in fact the upper atmosphere must be moving faster than the lower atmosphere to remain perfectly in sync. The upper atmosphere must be moving faster than the lower atmosphere. As is the case with any rotating sphere, the outer layers are moving faster than the inner layers. What force is causing the upper atmosphere to move faster than the lower atmosphere? If the atmosphere is being rotated solely by friction, then at best the upper layers would move at the same speed as the lower layers, thereby causing a spiral effect. Anyway, the first answer I got, or the longest answer I got, was from someone here called TPG. And anyway, and they said here, if your bucket this bucket of paint was to freely spin with the ball inside. So imagine that the bucket is suspended in air and the ball is just inside. So the outer wall of the bucket can begin to move. He said here, during this acceleration you have blah 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 blah. Basically what he's saying is the Earth doesn't have an outer edge, like the edge of a bucket. He said basically that if the entire bucket was allowed to spin enough time for the viscous forces to work, that it would all just move in sync. I think that's what he said. Oh, I missed a bit. Yeah, so there, eventually over a long time the outer edge of the bucket would spin at the same speed as the paddle inside it, which he means the ball, and you wouldn't see any spiral pattern. But this actually proves what I was saying, is that all that could happen if this ball was spinning, pulling the atmosphere along, at best this outer layer could move at the same speed as the inner ball. It would never move faster. And apparently the atmosphere is all moving in sync, which means the outer edge must be moving faster. And I actually calculated it here. So if the Earth's radius is 6371 kilometers, and the speed of the rotation at the circumference, at the equator, is 1670 kilometers per hour. Okay, so basically, the upper atmosphere layer, they call it the Karman line, is 100 kilometers high. So basically, if you were to add 100 kilometers onto the radius of the Earth, okay, you would get this 2 pi r. So basically, your new circumference is going to be 2 times pi times 6371 plus 100. So you get 40,658 is this outer circumference of the upper atmosphere. You divide that by 24, you get 1694 kilometers per hour. So you're talking 24 kilometers per hour faster. But where does that energy come from? There's no explanation for that. And I've actually changed my question on here. It's funny because all these people answered the original question, but as soon as I added that bit in about, I said if the atmosphere is being rotated by friction, then at best the upper layers would move at the same speed as the lower layers. We do not see this effect. Why? We see a spiraling effect. We do not see this effect. Why? And then no one answered me after that. They just all went quiet. All these people, these clever clogs, physicists, that all answered originally. They just go quiet when you ask them about that, which is interesting. Yes, so this guy, Felix, that jumped out of this Red Bull capsule, well, he was 40 kilometers up. So he should have been, the atmosphere up there should have been rotating a good 10 kilometers per hour or so out of sync with the ground. So he should have fallen at an angle. Or whatever, or you know, either everything would drop at an angle, or you know, what's the explanation for this extra energy? Okay, so that's the horizontal complications with Earth rotation, with the atmosphere rotation, and then on top of that you have latitude, lines of latitude across the Earth. So the Earth's rotation at the pole is 0. So therefore every degree north of the equator, the Earth's rotational speed is 18.6 kilometers per hour slower. So I asked another question here. Why doesn't the Earth's atmosphere form bands due to the different rotational speeds at each degree of latitude? If the Earth's atmosphere is rotating at the same speed as Earth, then the atmosphere must be rotating much faster at the equator than at the poles. If you were to spin a ball covered in oil, it would form rings. Also, Jupiter has rings, so why doesn't the Earth have rings, or where the two? Okay, and then I got this answer. The short answer is there are bands, apparently. Really? I don't see them. I see them on Jupiter. Lots of bands due to the spinning. We're supposed to be spinning at like 10,000 kilometers an hour or something. So you'd think you would see that. You know, there's no picture of the Earth I've ever seen that shows that. I've seen quite a lot of pictures of the Earth and you don't see that. So that's just not true. So that's it, basically. Two reasons why the Earth does not appear to show signs of spinning. Yeah, that's it. Thank you very much.